Peace everybody, my name is Corbin and welcome to my first installment in the mechanical engineering series. In this video, we will cover stress and related topics and include 2 example problems. So first of all, what is stress? Stress is the intensity of forces across a certain plane or cross-section in a member. If I were to take a large wooden beam and cut straight through the middle, the cross-section would reveal that there are 2 different kinds of stresses. Normal stress, which is directed perpendicular to the cross-section, and shear stress, which is directed parallel to the cross-section. In the general case, the internal normal force is equal to the integral of the normal stress with respect to the cross-sectional area. But in our cases, we will be calculating the average normal stress, which is equal to the internal resultant normal force divided by the cross-sectional area. And the same applies to shear stress, where the average shear stress is equal to the internal resultant shear force divided by the cross-sectional area. Our first example consists of a square cross-section with sides equal to 20 centimeters each. An internal resultant normal force of 20 newtons is applied at the centroid of this cross-section. What is sigma average? Seeing as how this is a direct application to what we learned about normal stress, we can just plug in the numbers, setting F equal to 20 newtons and A equal to the cross-sectional area, 0.2 meters times 0.2 meters. That is equal to 500 pascals. Observe the next example. We have a large beam that is attached via a fixed support to a wall, and a tensile 700 Newton force is being applied to the centroid of that beam. Knowing the dimensions of a vertical cross-section of the beam, we need to find the average normal and shear stresses on cross-section BB. In the upper right-hand corner of the screen, you can observe the internal forces, both normal and shear, at cross-section BB. Please note that whenever calculating normal and shear stress, the resultant internal forces, normal and shear, must always be applied relative to the cross-section at which you are calculating. Now we can apply common trigonometry in order to determine what F and V are. Form a triangle consisting of the 700 Newton tensile force, the internal normal force, F, and the internal shear force, V. Using their respective trigonometric functions, we find that F is equal to 350 newtons and V is equal to 606.22 newtons. Although we found the internal resultant normal and shear forces, we still need to find the dimensions of the cross-sectional area BB. This is easily calculable by forming another triangle and using trigonometric functions. We find that the height of the cross-sectional area is 100 millimeters. We now have the necessary information to calculate average normal and shear stress. Plugging in the numbers to their respective positions, we find that the average normal stress is equal to 70,000 pascals or 70 kilopascals. Calculate average shear stress in kind. Thank you for watching, and I hope that I was of assistance. Goodbye.